Hello friends, welcome to the Zeta Online Science Academy. Today we are going to discuss about part 3 of second chapter, which is isotopes according to the syllabus of O level 5070 2023, 24 and 25. If you are new at our channel, then kindly subscribe the channel and press the bell icon so that you get the notification of our every video. So let's start the video. What are isotopes? Define isotopes as different atoms of the same element that have same number of protons but different number of neutrons. Here is the definition of isotopes. It means that isotopes are the different atoms of the same element that have same number of protons but different number of neutrons. We can define it in another way. Atoms of an element that has same atomic number, because the number of protons are also known as atomic number. We discussed it in our previous lecture number 4. But different mass number, but because due to different number of neutron, the mass number also differs. Mass number is equal to Z plus N. It means that if number of neutrons are different, then mass number will be different, and Z is the atomic number. For example, if we see examples, then isotopes, hydrogen has 3 isotopes. The first one, it is also known as protium, it is known as deuterium, and tritium. Now you can see that all these atoms are of elements of hydrogen. It also has one atomic number, it has one atomic number, it also has one atomic number. It means that they have same atomic number, but they have different mass number. In other words, they have different number of neutrons. In first one, 0 number of neutrons are present. In this, 1 number of neutron is present, and in tritium, 2 number of neutrons are present. Their mass number are different. It means that these are 3 isotopes of hydrogen. Similarly, isotopes of carbon, 12, 13 and 14. Here atomic number is same but mass number is different, so these atoms are isotopes. Here also atomic number is same but mass number is different, 35, 37. So these are isotopes of chlorine. Let's move further. Now, this is provided in our course content that state that isotopes of the same element have same chemical properties. We also know that we discussed that isotopes have same atomic number. If they have same atomic number, it means that they have same number of protons, and if they have same number of protons, the number of protons and number of electrons are equal in an atom. It means that they have same number of electrons. If they have same number of electrons, then they have same electronic configuration. Electronic configuration is arrangement of electrons in shells. Arrangement of electrons in shell we discussed in detail in our previous lecture. Arrangement of electron in shells. They have same electronic configuration. If they have same electronic configuration, it means that they have same chemical properties. What is meant by chemical properties? Chemical properties are the properties that came due to bonding or chemical reactions or chemical change. And these chemical properties depends upon the arrangement of electrons in shells. This arrangement of electron shells determine the bonding and chemical reactions in atoms or elements. If now they have same electronic configuration, they have same arrangement, then it means that they have same chemical properties. I hope this is clear now. If isotopes have same chemical properties, then what is different in isotopes? How isotopes differ? As we discussed that isotopes have same chemical properties because of same electrons and same electronic configuration. Isotopes have different neutron number. If they have different neutron number, it means that they have different mass number and different nucleon number. If they have different nucleon number, it means that they have different physical properties. In physical properties, nuclear stability comes, radioactivity comes, and half-life comes. Nuclear stability indicates is due to nuclear stability is that the number of protons and number of neutrons and the nucleus of an atom should be uh, uh, a suitable amount of in other words, if number of neutrons are greater or far greater than number of protons, then the nucleus will be unstable and they disintegrates. It means that the phenomena of radioactivity will occur, and due to this phenomena of radioactivity, half-life also differs in isotopes. I hope this is clear. Now in course content, another thing comes, that is interpret and use symbols for atoms, i.e. carbon 6 or ions chlorine. He is asking that what this symbol shows information. What type of information this symbol shows? What these symbols are showing? If we see that carbon 612, this is a way of representing an element. In this way, we get some kind of information. What kind of information we get? Actually, by seeing this element, this central atom such as carbon, it is showing the symbol of element. In the center, the symbol of element were present. This is which is written below the symbol, like this one. It is said to be subscript, and the one which is written above the symbol, it is said to be superscript. The subscript of this symbol gives us information about the atomic number, and atomic number is the number of protons, and number of protons and electrons are equal in an atom. It means that this number 6, by seeing this number, we can say that the atomic number of carbon is 6, the number of protons, the 6 number of protons are present in the nucleus of carbon atom. The 6 number of electrons are revolving around the nucleus of carbon atom. This information we get just by this subscript of the symbol. And what this superscript shows, the superscript also shows the mass number, also known as nucleon number. By knowing by using the information of subscript and superscript, in other words, by knowing atomic number and mass number, we can simply calculate the number of neutrons by using this formula: n is equal to a minus z. Here we can say that its atomic number is 12, and its atomic mass or mass number is 12, and its atomic number is 6. Then the number of neutron will also be 6. So all this information are showing us by this symbol. For an ion, if we talk about ion, in an ion, ion is a species which contains positive or negative charge in it. We discussed it also in previous lecture. For an ion, Cl negative, Cl17 and 35, this subscript will also show the information of atomic number, and the superscript will also give information about atomic mass. And this negative sign, and the negative sign will give us information how many electrons are added into an atom. Therefore this negative sign is appearing. The one negative charge, it means that one electron is added in an atom. If two negative charge, it means that two electrons are added in an atom. So we can calculate the total number of electrons by simply adding them. 17 plus 1 is equal to 18. It means that 18 electrons are present in Cl negative. Similarly, if this notation in positive charge on the element on an ion, which is also known as cation, shows that how many electrons are lost from an atom. There were total 11 electrons in the atom of sodium. If one positive charge is present, it means that one electron is lost. Now the remaining electron will be 11 minus 1 is equal to 10. 10 electrons will be present in an ion. So by using this information, we do some practice. How many number of electrons will be present in oxygen? We can calculate 8 plus 2 is equal to 10, because it's showing that 2 more electrons are added in this atom. Ca2 positive is showing that 2 electrons are lost from in this atom. So 20 minus 2 is equal to 18. 18 electrons are present in calcium. Of Cl negative, it means that 1 electron is added, so total electron will be 18. Here F negative, one negative is showing that 1 electron is added in fluorine. So total number of electrons in fluorine will be 10, and in magnesium the total number of electrons will be 10, because the 2 positive charge is showing that 2 electrons are lost from this atom. So 12 minus 2 is equal to 10. I hope this is clear now. Now move further, and by using the information of atomic mass, we can calculate the relative atomic mass of an element. We can calculate the relative atomic mass of an element by 3 ways. By 3 different methods. I will discuss these also 3 methods. You can adopt any one method according to your convenience, or the one method that seems easy to you, or the one method that seems easy to you. Just give me a minute. Yes. The first method is calculate the relative atomic mass by using the information from relative atomic mass and abundance of its isotopes. What is meant by abundance? Abundance means that how much amount of an isotope is present. For example, chlorine has 2 isotopes, 35 and chlorine 37. I am not showing it, but by its atomic number, because this element has same atomic number, that is 17. So I am not writing it down. I am showing it's by its atomic mass, because it differs. And the chlorine is chlorine 35 is 75% present in nature, and the chlorine 37 is 25% is present in information atmosphere. So we can simply say that the abundance of chlorine 35 is 75%, while the abundance of chlorine 37 is 25%. This is meant by abundance. So by using the information, these first abundance and the relative mass of isotopes, we can calculate the relative mass of atom or average mass of an atom. It is also known as average mass of an atom. So let's calculate. The first formula is, I will show relative atomic mass by this notation. The R shows relative and A shows atomic mass. Relative atomic mass is equal to percentage abundance of first isotope multiply mass of first isotope. Similarly, percentage abundance of second isotope mass of second isotope. For example, chlorine 35 is 75% and chlorine 37 is 25 present in atmosphere. So we will calculate 75% multiply 37 plus 25% multiply 37. This percentage indicates that from 100 it is 75%. From 100 it is 25% present. So we will convert percentage into simple numbers. 75 over 100 plus 25 over 100. So it will become 0.75 and 0.25 multiplied by multiplying them and then adding, we can get 35.50. This is the relative atomic mass of chlorine atom. This is first method by using which we can calculate the relative atomic mass of chlorine. Now we are going to use the second method. I hope this first method is clear now. The second method is, in first method we separately divide the abundance of isotope with 100 but in second method we will multiply abundance of isotopes 1 multiply mass of isotope 1 abundance of isotope 2 mass of isotope 2, then we will the answer of this equation will be divided by 100 and we will get the same results. Let's prove it. 75% multiply 35, 25% multiply 37. So by multiplying these these two numbers, we will get these results, and simply by adding these numbers 35 or 3550 over 100, the answer will be 35.5 gram कह सकते हैं, gram per mole or AMU, whatever we usually denote by AMU, relative atomic mass. And this will be the relative atomic mass. So this is also a method of calculation of atomic mass. What is the difference between these two methods? I will repeat. The abundance of isotope first we will calculate by simply dividing everyone by 100, and in second method we will multiply these two numbers first and we will add them, and then we divide the whole result by 100. This is different between these two methods. And the third method is different from these two methods, which is that we first by the third method is a calculation of relative atomic mass by the ratio of abundance of these isotopes. How the ratio of abundance of these isotopes will help to calculate mass? Simply first, the first step will be find ratio of abundance of isotopes. In first step, find ratio of abundance of isotopes. Abundance of isotopes. Now we know that the abundance of isotope 35 is 75% and abundance of chlorine 37 is 25%. So we will take the ratio of the abundance of these isotopes 75% ratio 25%. When we simply them, we will get the simplest ratio 3:1. Now apply the formula. Apply the formula first. Also take the sum of these value 3 plus 1 is equal to 4. Now, what is the formula? Formula is this: first ratio multiply its mass, relative mass, and the second ratio multiply its mass over, and we will divide it by sum of ratio. For example, for calculating the isotopes of chlorine 3, we will multiply its mass number of its isotope 3 multiply 35 plus 1 multiply 25, and then we will divide it with its sum. By using mathematical calculation, we can get the same result. These are 3 different methods to calculate relative atomic mass. You have to remember only one method according to your convenience. The which one that seems easy to you, yeah, or you can use it easily. Another thing is that we can also calculate relative abundance of isotopes if mass number is given. These types of questions also came in our exams. How can we calculate relative abundance if masses are given? Here you have to apply some basic mathematics. You know that the relative abundance of all the isotopes should be equal to 100. Relative abundance of all the isotopes should be equal to 100. It means that if I represent the ratio of isotope 1 is equal to x, if the x can be any one number or can be any one digit. So if we simply represent the relative abundance of isotopes 1 by x, we can represent the relative abundance of second isotope by 100 minus x. It means that here if I assume x, the value of x is 25, and the relative abundance of second isotope will be 100 minus 20 is equal to 75. That is true. So while using these methods, why now we have two values. Simply apply them in any formula which we have studied. X, this is relative abundance, multiply 35, and the second abundance will be 100 minus x, multiply it with 37 over 100. By using that and by simply applying mathematical terms and simplifying, you will get the value of x. When you will get the value of x, you can find the abundance of other isotopes also. I hope this is clear. Now we will do some practice so that we become clear to this topic. The first MCQ is, what is mean by isotopes? Isotopes are atoms of same element with different masses. This is also correct. Atoms of different elements with different masses. This statement is correct, but this is not correct for the isotopes. Atoms of different elements with their same mass. No, isotopes does not have same mass, but this statement can be correct in a way. Different isotopes, different elements can have same mass. It's possible. Atoms of same element with same mass, this statement can be true, but it's not true for isotopes. Atoms of same isotopes element with different masses, this will be true for the isotopes. The second statement is that, which one of the following statement concerning to isotopes carbon 6 and nitrogen 14 are correct? You can simply Check the statement. Both isotopes have same chemical properties. Here you know that chemical properties depends on atomic number. I am saying atomic number. Actually, it is number of electrons, because atomic number is equal to the number of electrons. So we can say that the chemical properties depends upon number of electrons. Carbon has 6 number of electrons, while nitrogen has 7 number of electrons. It means that this statement is correct. They cannot have same chemical properties. The second statement is both isotopes contain 14 nucleon per atom. Yes, this statement is correct. Both atoms have 14 nucleon. Carbon 6 is also has 14 nucleon number, and nitrogen has also 14 nucleon number. So this statement is correct. The carbon isotope has more neutrons per atom than nitrogen isotope. We can calculate the number of neutrons by simply using the formula A is equal to Z minus N. Then number of neutrons will be equal to A minus Z. For now apply this formula for carbon. N is equal to sorry, here is not 12. Simply in usual practice we used 12, therefore I wrote it here. The atomic mass given is 14. 14 minus 6 is equal to 8. 8 number of neutrons per nucleus. Now we can calculate for nitrogen also. 14 minus 7 is equal to 7. It means that carbon has more number of neutrons per nucleus, while nitrogen has less number of neutrons. So this statement also saying carbon has more neutrons per. So this statement is also correct. So our required option will be first two and three statements are correct. This is wrong. No, first statement is wrong. 1 and 2 are only correct. This is also wrong, because 2 and 3 are only correct. Yes, this option is correct. Only 2 and 3 are correct. The correct statement will be this. Now move further. This is a question where we will also use some kind of mathematics that I described you in the lecture also. The element chlorine has two isotopes, chlorine 735 and chlorine 37. And in periodic table, chlorine is shown 35.5. It means that the relative atomic mass of chlorine is 35.5. This is given to us. Which row shows the correct percentage of each isotope? Correct percentage of isotope, it means that they are asking us to calculate the abundance of isotope. Simply, now we have to calculate abundance of isotope. I am saying the abundance of chlorine 37 is X, and the abundance of chlorine 37 is X minus, sorry, 100 minus 100 minus X. Why I am writing this 100 minus X, I explained in lecture also. I will also repeat, because the sum of the relative abundance of these isotopes will be equal to 100. If my x1 plus x2, if I denote it, then it will be equal to 100. Therefore, if the value of x is known, then we simply subtract it from 100, then we will get the value of x2. Now apply the formula. Relative atomic mass is equal to abundance of first isotope, x multiply 35 plus x minus 100 multiply 37 divided by 100. Here is given to us 35 5 multiply 100 is equal to 35x plus multiply it with these two zeros plus 30. Sorry, I am repeating the mistake again. This is not x minus 100. This is 100 minus x. 100 minus x. So we will write 3x minus 35x plus 3700. So this will 3550. If I multiply those 35x minus 37x, I will directly wrote it minus 2x. This is simple algebra calculation. Minus 2x plus 3700, 3550 minus 370 is equal to minus 2x. So 3550 minus 3700 is equal to minus 150 is equal to minus 2x. The 2 is multiplying, so if it comes to other side the equation, it will divide. I am writing it here. X is equal to minus 150 or minus 2. So the value of the relative abundance of isotope 1, which is chlorine 35, will be 75. Now calculate the relative abundance of other isotopes. Simply 100 minus x, 100 minus 75 is equal to 25. Here now we can see our options. In third last option D, we can find the percentage of chlorine 35 is 75 and the percentage of chlorine 37 is 25. This is our required option. I hope I made this question clear to you guys. Now move towards the last query of today's lecture, which is two isotopes of chlorine are given, which are chlorine 35 and chlorine 37. A compound is given to us C2H3Cl3. The examiner is asking how many different relative molecular masses are possible for this compound. We can simply write it C2H3Cl3. It means that 3 chlorines are present here. While chlorine has 2 isotopes, first, the compound, it is possible that these all 3 chlorines have relative atomic mass of 35, 35, 35. All these chlorines should have relative atomic mass 37, 37, 37. The third option is all these chlorines should have one isotope of 35 is present, while other 2 isotopes are of 37. And the fourth possibility is the one isotopes of 37 is present, while other all isotopes are of 35. So here no other possibility is possible. So we can simply say that 4 different relative molecular masses can be calculated for this compound, because as we saw these possibilities. So all this was about today's lecture. I hope everything is clear. If you have any query related to this topic, you can simply ask me in comments. If you want to join free O-level session, I will put the Google form link in description. You can go and fill the form and enjoy the opportunity of O-level free session. Good luck. We will continue chapter number 2 in our next lecture. Thank you so much.